Let me confirm which line. Okay, is on now. That is very bad. I'm suspecting the mic. All right, guys. Good evening, everyone. We are about to start our class now. Please, if you're online, indicate that you're online. Indicate that you're online. The network is actually bad tonight, but we're going to keep on learning until we are done with this physics tonight. Please, if you're online, indicate your presence that you're online. If you're online, indicate that you're online. Please, if you're online, indicate your presence that you're online. If you're active, indicate. We are about to start. Still on physics. This time around, we have been looking at projectile motion. Projectile motion. Once we are done with this, we'll move down to Newton's laws of motion and the law of the principle of coefficient of restriction, collision theory in physics, momentum, and so many other topics we'll be looking at tonight. But tonight we'll focus our attention on projectile motion. Projectile motion. Please, if you're online, indicate that you're online. Please, let's keep on sharing. Keep on sharing the link. Keep on sharing. If you have shared, say it, I've shared. Please share the link. Share the link. Share the link. We have just few minutes. Please share. Please share the link. Share the link. Only one person is active. Okay, Chimaya, I can see you. Anthony, I can see you. Austin, I can see you. Please, let's keep on sharing. We're about to start. We are about to start. We are about to start. In few more minutes, we are starting. Please, let's keep on sharing the link. Please, if you are active, indicate your presence that you are active. We have 3 persons on the line. Once we are up to 5 or 7, we'll start. Please share the link. Share the link. Please share the link to your friends. Keep on sharing. 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 All right. Let's keep on sharing the link to others. Let's keep on sharing the link to others. All right, guys. So we're going to start now. We're looking at projectile motion or projectile in physics. Then after this, we'll move into Newton's laws of motion. Then we go into other aspects in physics. We solve the past questions and all that. early hours of today, we talked about dimensional analysis, and I was able to um, go deep into dimensional word analysis. And I gave an assignment. I also dropped my phone number. Only few persons actually comply with the assignment, but nevertheless, I will continue with what we have here. Okay. Please, if you have done your assignment, don't forget to drop the solution. This is my WhatsApp number 09063111961. Please drop the solution of your assignment, okay, on my WhatsApp. This is the WhatsApp contact. This is also my active line. All right. So let's go into projectile motion. Projectile, we know, is a body in which, when launched into the air, moves in a parabolic path under the influence of force, gravity. I repeat again, projectile is a body or an object in which, when launched into the air, the body must move in a parabolic path under the influence of force of gravity. So this is a projectile pathway. It's a body in which, when launched into the air, the body must be launched into the air, right? The body must be launched into the air, and the body must have to move in a parabolic path or a trajectory path under the influence, meaning that the body must have to return back to the earth. The body must return back to the earth. The body must return back to the earth. Okay, now there is an angle called angle of what? Projection. This is the angle the resultant velocity or the resultant line is making with the x-axis. Okay, is making with the x-axis. We call that angle of what? Projection. In mathematics, we call this angle of elevation. Angle of elevation. All right. Okay. Now I want us to quickly look at examples of projectile before we analyze some cases here, because there's a lot of things I'll be talking about here, and I will try as much as I can to summarize everything within a short period of time, because I will not be going deep into it, because we have a lot of things to cover in physics. All right. Examples of projectile we know is a launch, a thrown javelin, okay, or a fired bullet. When you throw a javelin or when you fire a bullet from a gun, okay, such objects tends to move in a parabolic path. Okay, another example is a played tennis. A played what? Tennis. These are examples of projectile. Any objects that have a tendency to move in a parabolic path, and that object is being influenced by gravity, is called a projectile. It's called a projectile. Now, I want us to look at some fundamental assumptions. You have to take notes. Fundamental assumptions in projectile. Fundamental assumptions in projectile. The first assumption we must have to take note in projectile is that there is no air resistance. Air resistance is negligible. That means all throughout projectile motion or projectile motion rather, we are ignoring air resistance. We are ignoring air resistance. And if we should ignore air resistance, it has an implication. The implication it has is that since air resistance is ignored, it simply means that initial velocity in the horizontal component is equals to final velocity in the horizontal component. That means the initial speed horizontally, the speed the body starts with, okay, must be the same speed the body must end with. Because why? We are ignoring what? Air resistance. Are you there? Meaning that if the body is being projected with ux equals to 20 meters per second, this same us, the body will land with it at vx equals to what? 20 watts meter per second. That is the implication, because why? We are ignoring what? Air resistance. Number two fundamental assumption is that acceleration due to gravity is constant and it always acts vertically what? Downward. Okay? G is constant. G is constant and it acts vertically what? Upward. And the implication to this is that vertical acceleration of projectile is always equal to minus G. Minus G. Vertical acceleration is always equal to what? Minus G. Please take note that acceleration is constant and it always acts vertically downward, meaning as the body is being projected, there is always a force of gravity that tends to pull the body down. So this acceleration due to gravity is always acting on the body. As the body is moving up, it's pulling the body downward. Are you there? So because it is against the projectile motion, so as the body is being projected, since it's acting against the motion of the body, it's taken as what? As negative. Don't forget that we talked about a force. Whenever a force is acting against motion, that force is taken as negative. So as the body is being projected, okay, the force of gravity, the constant value G, is always pulling the body towards the earth. So vertical acceleration is equal to negative G. And don't forget that our G is our 9.81 meter per second square. So that means our AY is equal to what? Minus 9.8 meter per second square. Minus 9.81 meter per second square. These are the two fundamental assumptions and all that. The third one from other materials is that the shape of the earth or the earth rotation is also ignored. We don't put into consideration the nature of the earth when the body is being projected. But the major two is that air resistance must be ignored, meaning as the body is being projected, we don't care if there's any air resistance. We don't care if there's any air resistance, so we ignore it. All right. And once we ignore that, don't forget the implication is that US must be equal to what? Vx. Then G must be constant. And if G is constant, if G is constant, the value of G tends to act vertically upward, right? Okay. So if G acts downward, that means our vertical acceleration is equal to negative G. Now I want us to look at something very important. Please, if you're online, please indicate your presence. If you are following, if what I just said now you understand it, indicate. Just tell me that you are following, so I can know those who are following. Because if you don't understand these fundamental assumptions, it will really affect you in the throughout our journey. Because some questions have to involve this. So if you don't understand this, it will affect other aspects. So please, if you are following, just indicate that you are following, please. Okay. Another thing I want us to look at is what we call mathematical framework. We have two mathematical framework I want us to discuss about. Two mathematical framework. We say that when the body is being released, this is the release point, right? The point where the body leaves your hand. When the body is being released from here, the body moves in this trajectory pathway, right? Now, the speed at which the body moves is called what? The initial speed. Is that clear? Okay. The initial speed. Then, if you look at this, we have an angle here. The angle here is called theta. It's called the angle of elevation, right? This speed here can be resolved into two components. I can create a right angle triangle here. Okay. Then here we have here to be UY. Here we have it to be what? To be UX. We have here is our UY. This is called what? Our US. I'm resolving this. Don't forget that when the body is being projected, listen, the body is not just moving horizontally. The body is not just moving vertically. The body is moving both UX and what? UY. At every point, we have our initial horizontal and what? Vertical, right? Vertical. Then at some point, the body changes to what? V, right? Vx and what? And Vy. Then I will explain some terms there. Because at this point, at the maximum height, something actually happened here. Vy is equal to what? 0. And I will explain most of these things for us to understand. But let's look at this mathematical framework first. Let's resolve this initial speed. We are assuming that the speed at which the body moves is called the starting speed, right? Which is the speed at which the body lifts your hand and all that. And that speed is called initial, which can be resolved into uy and what? Ux. Now, in vector resolution, if this is our, okay, let's use the word velocity, right? If this is our initial velocity, this is the initial velocity in the vertical component. This is our what? Initial velocity in the horizontal component. We can resolve us with respect to u and uy with respect to what? To u. I've taught us this in vector resolution that whenever a force or whenever a vector rather, or sorry, whenever an angle of inclination is along the x-axis, the angle is along the x-axis, that us can be resolved as u cos theta. If you are following us all this while, we have learned how to resolve vectors. But let me show us how we got this. Listen, resolving ux, I will resolve us with respect to u. Us here is called the adjacent, right? This part is called the adjacent. Here we call here the hypotenuse, the longer side. So when you use the word SOHCAHTOA, from the word SOHCAHTOA, right? CAHTOA. So if I'm considering my adjacent and my hypotenuse, it simply means I'm going to use CA. I'm going to say using cos theta. The word cos means adjacent over what? Hypotenuse, right? Adjacent over hypotenuse. Adjacent from here to here is our ux. What is our hypotenuse? That is our u. So by the time we cross multiply, it means that our u equals to what? U cos what? Cos theta. Equation 1. Then resolving uy with respect to what? Hypotenuse. Uy here, this side represents what? The opposite. Because any side that faces the angle is called the opposite. Then the longer side is called what? Hypotenuse. It means I will use so to resolve. I'm going to say using sine theta. And sine theta equals opposite over what? Over hypotenuse. What then is our opposite? Uy. What is our hypotenuse? U. So that will give us uy divided by what? U. By the time we cross multiply this, uy times 1, that will give us uy equals to what? U cos what? Theta. You have to take note that in projectile motion, anytime you are given ux represents u cos theta. Us simply means initial velocity in the horizontal component, while uy means initial velocity in the vertical what? Component. U represents what? Initial speed, or the resultant initial velocity. Resultant initial velocity. Alright. Theta here means our angle of forward projection or angle of elevation. Are you there? Now I want us to further look at other aspects of projectile. I hope I can claim. Please, if you are following, indicate that you are following. Please indicate that you are following. If you are following, indicate that you are following. Okay, someone said, I am not following. Okay, let me repeat again. People came in late. That's why I don't like you guys coming in late and all that. Let me just repeat. So pay attention again. We have defined a projectile as a body that moves in the parabolic path, right, under the influence of gravity. That when you launch a body or when you throw a stone, the body tends to move in the path in this pathway. Is that clear? In this pathway. Are you there? Now, when the body moves in this path, the body must have to return back to the earth. Is that clear, somebody? So any object that undergoes this process is called what? A projectile. A good example is a launch, let's say a thrown stone or a thrown javelin or a play tennis, or a kick football. A kick ball. When you kick a ball, the ball tends to move in this pathway. Then we say there are two fundamental assumptions. Why do we call them assumption? Because they are assumption because if you look at it in nature, they exist, but we have to assume that they don't exist. Are you there? Now, assumption, two assumptions in projectile is that air resistance is negligible. Air resistance, meaning that when a body is being projected, we are neglecting any other thing, any other external resistance. We are neglecting air resistance, although there's air resistance, but we are neglecting what air resistance. Okay? That means we are assuming that the body is being projected in a vacuum. Are you there? But the general concept is that the first assumption is that you must have to neglect what air resistance. And once you neglect air resistance, we now say that the implication is that Ux must be equal to what? Vx. Where Us represent, I will show us how to derive this. I will prove this. All of this is I just stated now. I have to still prove it. I will show you the proof why Us equals to what? Vx. But just take note that from the assumptions we take note of, we are saying that Us must be equal to what? Vs. That's the assumption. Number two is that acceleration due to gravity is constant. We know it's constant. What's the constant value? 9.81. But because it's constant, it's always acting downward. When the body is being projected from here, listen, the body is accelerating, right? Along the vertical axis. The body is not accelerating along the horizontal axis. In a projectile motion, Ax is equal to 0 meter per second squared. Whenever a body is being projected, because we are neglecting air resistance, okay, that means that the body is only moving along what? The vertical component. The vertical what component. There is no horizontal one acceleration. It's like anytime a body is going up, the body is not accelerating. When a body is moving along the x-axis, it means that the body is only accelerating along the x-axis. It means there's no vertical acceleration. But whenever a body is going up, that means the body is only accelerating along the vertical axis. That means we have vertical acceleration. So that means any object thrown upward, we are saying that there is no horizontal acceleration because the body is being thrown is being thrown upward. So the first assumption I've mentioned is neglecting air resistance. Number two is that gravity is constant and it always acts vertically downward. So if gravity is constant and it acts vertically downward, and the only acceleration we are considering is what? Is AY. That AY must be equal to what? Minus G. Why is it minus G? Because as the body is accelerating upward with AY, right? There is a force, a pull towards the earth. Because G is always acting downward. But because G is acting downward, it's acting against this. It becomes what? It becomes negative. It becomes negative. It's acting against direction of motion. It's acting against vertical acceleration. The body is accelerating upward. There's a force pulling it downward. Is that clear? For the body to move with a constant speed as it's going upward, these two forces must balance each other. But the value of our G will be negative. Reason because this G here is acting against the acceleration of the body as the body is being projected upward. I hope it's clear now. So please tell me in the comment section if it's clear. Projectile motion can be somehow confusing, but if you can understand this basic I just said, I don't want to rush into the terms used in projectile, time of flight, maximum height. These are the basic things we all know. But all of these are very necessary because your exam question will demand this. While calculating, we'll solve some of your exercises. We'll solve some of your examples in your textbook. We'll solve some of your exercise, even your past questions. Then we'll also see how we can apply most of these principles I just mentioned. All right. So please tell me in the comment section if you are following or not. Yes, someone mentioned something. Thank you so much. Someone corrected us. Here we say that US equals U cos theta, right? Thank you for that observation in the comment section. We made a mistake here. UY is meant to be U sin theta, right? From here, when you cross multiply this, UY times 1 is UY, sin theta times U is what? U sin theta. U sin theta. Thank you. Now, this part, I want to repeat again. This part. For those who just came in, please don't come late again. Don't come late again. Once you see the notification, leave everything you are doing and come online. We say that when the body is being launched, the body is being released from your hand. The body is being launched from this point. Is allowed to move from this point upward. The body moves with an initial speed. Then we generated a right angle triangle along this pathway. Okay. Any object moving in a parabolic path like a projectile must always exhibit two components of initial velocity at the starting point, which is what US and what UY. US means initial velocity in the horizontal component, while UY means what? The vertical what? Velocity, okay? Vertical velocity or vertical initial what? Velocity. Is that clear? Then we can resolve these velocities here. We can resolve US and resolve what? UY. The sum of these two velocities, Vy and Vs, is equals to this U. That means as the body is moving with initial velocity, it's moving with both Uy and what? Us. Don't forget. As the body is moving with initial velocity, you projected the body. The body is being given an initial speed. That initial speed has two components. The first component is what? Is US. Second is what? Is UY. Okay, so we can resolve this. Looking at US here is along the adjacent. This is what? Hypotenuse. So from the word SOHCAHTOA, from the secondary school, we all know what the SOHCAHTOA, right? The word SO means sine. S means sine. C means cos. T means what? Toa. So if I have my adjacent and my hypotenuse, which of these three will be used to resolve for US? It's simply cos. So I will now say using cos what? Theta. The word can means adjacent over what? Hypotenuse. Our adjacent is US. What our hypotenuse is U. By the time we cross multiply, the US times 1 is what? Is US equals to what? Yeah? U cos what? Theta. So anywhere you see US, it means what? U cos theta. Then for the vertical, I will resolve UY with respect to what? U. So UY here represents my opposite. This represents what? My hypotenuse. Is that clear? So that means that looking at opposite and hypotenuse, the right thing to use is sine AB. So I'll say using sine theta equals to opposite is UY over what's our hypotenuse? Is U. By the time we cross multiply, UY times 1 is UY equals to U sine what? U sine theta. So whenever you see US throughout projectile motion, it represents U cos theta, while UY represents what? U sine theta. So please, are you now following now? For those who just came in. All right, so let's continue. Now let's look at kinematics. Kinematics equation. Kinematics equation. I think I have to plane this body from here. Kinematics what? Equation. Let me just bring it out from here. The body is so small. Please bear with me. Okay. Kinematic equation in projectile. How do we describe the equations, some equations in projectile? Kinematic talks about the study of the motion, right, of a body, all right, without involving the force that causes what the motion. That's called kinematics. So let's look at kinematics equation. We'll look at the horizontal components. All right. Now, in kinematics, there's what called equations of motion. Equations of what? Of motion. Please listen. The first one we have is V equals to what? U plus what? 8. The second we have is X equals to UT plus half 80 squared. The third we have V squared equals to U squared plus 2AX. I'm going to use these three equations to form the kinematic equations that will be a very important tool for us to solve any problem under projectile. If you can understand this aspect, one, understand the fundamental assumptions in projectile. Then number two, if you can understand the resolution we did, which is US equals to U cos theta and UY equals to U sin theta. Number three, if you can understand the kinematic equations, we'll be looking at both horizontal and what? Vertical. Then also understand the basic terms, which are time of flight, maximum height, range, and so many other ones. There is no question in this world in projectile that you cannot solve. The challenge has always been these fundamentals in projectile. It has already been these fundamentals in projectile. Okay? So please let us pay attention. The first one we have here says V equals U plus 80. If I'm bringing out the equation, okay, the equations using the horizontal components, all right, of this equation here. The first one we have is called what? It's called V, right? V equals to what? U plus what? 80. If since we are considering kinematics means the motion of this body, we want to analyze it using the equation of what? Motion. I want to analyze the equation of this body as the body moves from point A, all right, to point what? To point B. We want to analyze the equation. So for horizontal, anywhere we have V, I'm going to put Vx here. I'm taking all of these parameters as what? Horizontal what? Parameters. So here I have Vx, I have here as what? Ux, here as what? Ax. You know, I say that whenever we ignore air resistance, that Vx is equal to what? Ux. Right? The first fundamental assumption in projectile is that air resistance is being neglected. Air resistance is neglected. meaning there is no sideways pulling or what push. Like if a body is moving along the horizontal what, so it's being projected this way. It's being projected this way. Okay, the body is only moving along what vertical what axis. Do you get the concept here? Well, now the implication of ignoring air resistance. If we ignore, we ignore air what resistance. What does that mean? Is that as the body is being projected, if there's air resistance, instead of the body to move this way, it might divert. If there's air resistance, let's say the body is projected and there's air resistance, maybe a movement of air particles, it will just move the body sideways. But we are neglecting it. You can see why it's a very big problem. We're neglecting it. Now, if we are neglecting air resistance, that means we are saying that the body is not moving horizontally. Because if we do not ignore air resistance, that means the body is also moving, it's also accelerating horizontally. There's difference between acceleration and speed. Are you there? Ignoring air resistance simply implies that our horizontal acceleration is equal to what? 0. Ignoring air resistance simply implies that horizontal what? Acceleration is equal to 0. Meaning the body is only accelerating vertically with what? With AY. Don't forget. Since the body is only accelerating vertically, I will say AY is equal to what? Minus G. Please don't forget this. So whenever we ignore air resistance in projectile, the implication is that horizontal what? Acceleration must be equal to what? 0. Because the body is just moving only vertically. There is no horizontal what? Acceleration. Am I communicating? If that is true, so that means that our Vx is equals to what? Ux plus what? 0 times what? T. Is that clear? So our Vx is simply equals to what? Somebody? Ux. But recall that we have only defined that Ux is equals to what? U cos theta. We define this, don't forget. So if Us equals to U cos theta, does that mean that our Vs is also what? Ux, which is also what? U cos what? Cos theta. Please take note of this. Very important. Take note of this. Vs is Ux. At every point, from this point here, as the body being projected, even down to this point. Even down to this point, the value of our Vs equals what? Ux. Even as the body is coming down, it's also Ux. You know, I said before now that if we should ignore air resistance, that means the initial speed along the x-axis, the speed at which the body is moving with along the x-axis, which is Ux, must be the same speed at the ending, which is what? Our Vx. That is the implication there. So you must have to take note that whenever we say ignore the air resistance, it means that As must be equal to 0. Then from this equation here, we notice that Vs equals to Us. When we say Us is what? U cos theta. Now let's look at, even if I'm to use this equation, V square equals to U square. Look at it very well. Even if I'm to use, I will just use, then I will clean it. If I have V square x, right, equals to what? U square x, right, plus what? 2ax times x. From here we have our what? Vs squared equals to what? Us squared plus 2 times 0 times what? Times s. So we are left with what here? V square x, V square x is equals to what? U square what? X. Are you noticing something here? So this is already off. I can square root both sides to cancel out square. If we should square root both sides, that will give us what here? Vs equals to what? Us. Whether you use this or this, your Vx must be equal to what? Ux. Whenever we ignore what? Air what? Resistance. Now let's move on. Let me quickly clean here. Let's now look at what will happen to our displacement. Also, recall that displacement is equal to what? Ut plus what? Half what? At squared. Because we are considering horizontal, I will change this to what? To represent x. That x, if I'm considering vertical, I will change this to be what? To be y. But because I'm considering the horizontal component, s becomes what? The normal horizontal x-axis, right? Equals to what? Yeah? uxt plus what? Half what? Half ax what? T squared. Already you know what will happen here, right? And as is equal to what? 0, because we are ignoring what? A resistance. So x is equal to what? Yeah? ust plus what? 0. Because as is 0. Okay? 0 times half t squared is what? 0. So that means that we are left with x equals uxt, which is same as our us, remember, is what? U cos theta, then times what? Times t. Please take note of this. Then let's look at vertical now. Vertical what? Components. The first one we look at, just like we did here, we use vx us plus as. I will change it to what? Anywhere I see s, I'll put what? Y, right? So I'm considering the vertical, which is the y axis. So that will give me what? Vy equals to what? Uyt plus what? Ay what? T. Are you there? Vy equals to Uyt plus Ayt. All right. Don't forget that we say something very important about one of the fundamental assumptions is that acceleration is what? Is constant, right? And it is always directed downward. And what is the implication to that is that Ay is equal to what? Minus what? G. What does that mean? Anywhere we see Ay, I will replace Ay with what? With minus G. So that means my Vy will then be what? Uyt minus what's that? Ay gt. So that means our Vy will then be equals to what? From here, our Uy, we have already resolved Uy. We resolved Us, right? Sorry. We resolve Us as U cos theta. Then Uy is what? U sin theta. Here becomes what? U sin what? U sin theta times t minus what? Minus gt. So that means our Vy is equals to what? Yeah? Okay, I can actually stop here for Vy. I can stop here for Vy. I hope this is clear. I've already explained this, except those who are just coming. I've already explained this. I won't go back again. Maybe after this class, you can always go back and watch and listen to my voice notes on the fundamental assumptions and other key things I mentioned. All right. So let me know if you are following in the comment section. Let me know if you are following in the comment section. Let me know. Are you following? If you are following, please indicate that you are following. Indicate that you are following in the comment section. Please indicate. Now let's also look at just like we did in this first one here, that we said S equals to what? Ut plus half at squared. I will represent x-axis, right? For horizontal. It means I will represent this my x as what here? As y, right? I'll say y. So if I have x, here becomes y, right? Okay. Equals to what? Equals to uyt, right? plus what? Plus half AY T squared. So here becomes Y equals to, our UY is already U sine theta times what? T. AY is minus G. And that will give us what here? Minus half, okay? Half GT what? Squared. Minus half GT squared. Okay. Now let's proceed. Let's finish up from what we have. Then our Y becomes U sine theta times T minus half GT squared. Okay. So please take note of this. If you are following, please indicate from the comment section that you are following. Please indicate that you are following. Indicate that you are following. Please indicate that you are following. All right, so let me show you one more thing. Okay, we say that if we have a body, right, being projected, there's something I wanted to show us here for us to take note of. Please take note that at this point here, our vertical speed is equal to what? 0. Do you know why it's 0? It's 0 because as the body is being launched here, the body gets to the maximum. The only velocity here is what? Is horizontal what? Velocity. Before the body, as the body is being launched, before the body returns, the body is moving only along what? The horizontal what? Axis. And when we have only horizontal velocity, that means vertical speed is what? Is 0. So at this moment here, at this point, before the body returns, the body only moves along the horizontal what? Axis. So Vy is equals to what? 0. Vy is equals to 0. But don't forget that at every point from here to here, at any point from here to here, down to here, the value of our Us is equals to what? Vs. Why? Because we are ignoring what? Air resistance. Now let's look at what we call some basic terms. Some basic terms using projectile. Some basic terms using projectile. Some basic terms used in projectile. Number one is what we call time of light, right? Time of light. I will not be deriving, I'll just be explaining, then we can move forward. Or time to reach the greatest height. Time to reach the greatest height. Time to reach the greatest height. Or small t. Time to reach the greatest height. This is the time taken by the projectile to attain the maximum height, meaning as the body is being projected, listen, the body is being projected from this point A to this point here. Let's say here we have point what? B, and here is point C. There's a time taken to move from here to this point here. Okay, that time taken is called what? Time to reach the greatest height. From this equation of motion, when we have Vy equals to what? Uyt minus what? Gt. We can get the formula for finding what? Time to reach what? The greatest height, right? From here, let me explain. Any time covered from here to here is called the time to reach the greatest height. And what happened here is that at this point here, don't forget that we said that Vy is equals to 0, right? So from here, if we are saying that, if we are given, I don't want to derive, but I'm being tempted to derive. If we are given that Vy equals to Uyt, right, minus what? Gt. All right, and we have Vy equals to what? Uy is U sine theta times T minus, okay, let's see. Okay, no, not from this expression. I'm sorry for that. I'm sorry. From this expression, V equals to what? U plus what? 80, right? So if you're looking at Vy equals, what will be here is what? Uy plus what? Plus, okay, plus Ayt, right? Then we are saying that Ay is equals to what? Minus G. Don't forget. That will give us what here? Vy equals to what? Uy is U sine theta. Then Ay is what? Minus G what? T. Now don't forget that when the body gets to the maximum, we say that Vy is equals to what? 0. What do I mean by that? I'll repeat again. For those of you who are just coming in. If I have a projectile this way, a projectile is being launched. At this maximum, since I'm waiting for time to reach the maximum, it means I will consider from here to what? To here. From this point here, Vy is 0. I explain why, because along this point here, the body is only moving horizontally. So there is no vertical speed here, or no vertical velocity. So Vy is 0. So from here, since our Vy is 0, if Vy is 0, here becomes what? Here becomes 0 equals to what? U sine theta minus what? Gt. By the time I move this minus gt to this side, it becomes what? Gt equals to what? U sine theta. Then our t becomes what? U sine theta divided by what? G. So this is the formula for finding time to reach the greatest height, which is what? U sine theta over G. So this time here is the time covered from point A to this point here. So the time here is what? T equals to what? U sine theta over what? Over G. Are you guys following? Please, if you are following, indicate that you are following in the comment section. Indicate it, indicate. This is not a new thing. I've already explained this before I come to this side. I'm just showing us that we can be able to derive the formula for finding time to reach the greatest height. And why do we say that? Because at this point here, our Vy is what? Is 0. Vy is what? Is 0. Because at the greatest height, Vy is 0. So that means we can solve with this, and that will give us what? Our t equals to U sine theta divided by what? By G. All right, so let's look at the second term. The second term is time of light. Time of light. When you do what time of light, it means total time taken. The time taken to move from point A to this point, then returns to the Earth. From point A to B, then to point what? C. That's called the time of light. This is the time taken by a projectile to move from the point of projection to the point where the projectile hits the projection plane. All right? The time taken for a projectile to move from the point of projection to the point where the projectile hits, HITS, where the projectile hits the projection plane. That's called the time of light. And look at this. This parabolic curve here is actually symmetrical. Is what? Symmetrical. Meaning that the distance covered from here to here is same as from here to here. So if the time taken to move from point A to point B is simply this, that means the same time must be covered from here to here. Are you there, somebody? Another thing again you should take note is that the time taken to move from point A to B can also be called time is taken to move against gravity. Because as the body is going upward, the body is assumed to move, is going against what? Against gravity. Gravity is always pulling it downward. So from point A to B, which is our time to reach the greatest height, or the time taken for a body to move against what? Gravity, right? The time taken against gravity. Then this is the time taken to move towards gravity. Exactly. Uh-huh. To move toward, because from here the ball is being pulled by towards the earth. Gravity uh, pulls the body towards what? The earth, right? So since this shape is symmetrical, that means the distance from A to B is same as from what? From B to what? To C. Okay, so if from A to B is this, that means the same time is taken or is covered from B to what? To C. So that means that in essence, our time of flight is simply, if from here to here is small t, this also what? Small t, right? So it's simply t plus what? T. So our big T is equals to what? 2 small t. That means our time of flight equals to what? 2. Our small t is simply what? Is u sine theta over g. That will give us what here? U sine theta divided by what? By g. Are you there? I can as well use the equation of motion to derive this, but I don't have that time. Let us proceed into something else. Number 3 is called maximum height. Maximum height. Please, if you are following, indicate that you are following. Maximum height. Please, if you are following, indicate that you are following. Please indicate, indicate, indicate. Number 3 is maximum height. Maximum height. What is maximum height? Maximum height is the highest vertical distance attained as measured from the horizontal projection plane. Maximum height is the highest vertical distance attained. The highest vertical distance attained as measured from the horizontal projection plane. That's called the maximum height. Alright? And by formula, maximum height is given as u square sine square theta, all divided by what? By 2g. Okay? Maximum height is the highest vertical distance attained as measured from the horizontal projection plane. This is the formula for maximum height. The next one, number 4, is called the range. The range, also known as what? RS, right? Also called horizontal distance. Horizontal distance, right? Distance. When you hear the word range, range simply means horizontal distance. Distance covered from this point here to this point. Exactly. That's called our range. Range is defined as horizontal distance covered from the point of projection to the point where the projectile hits the projection plane, and range is given as US times time of light. Don't forget what US represents. US represents what? U cos what? Theta, right? Range is also given as RS equals U square sine 2 theta divided by what? G. Divided by G. Range is either UST, where US represents U cos theta, YT represents time of light, right? 2U sine theta over G. Then, or we can, from this evaluation, I can derive the formula for range. So that will give us what? U square sine 2 theta divided by what? G. That is our range. Now, the next one I want us to look at is called the maximum range. Maximum range. Maximum range occur when sine theta is equals to, or rather, when theta is equals to what? 45 degrees. Maximum range occur when theta equals to what? 45 what? Degree. when theta equals 45 degrees, or when sine theta is equals to what? 1. When sine theta is equals to what? 1. Yeah. So from here, I can find the value of my theta, right? Sine inverse of 1 is 45. So when sine 2 theta, not sine theta, when sine 2 theta rather is equals to what? 1. Maximum range occur when theta equals 45, or when sine 2 theta equals to 1. From here, we can find our angle here. Our 2 theta equals sine inverse of 1, right? 1.000. So that means 2 theta is equals to what? Sine inverse of 1 is 90 degrees. Exactly. From here, I can find theta by dividing both sides by 2. And that will give us what? Theta is equals to what? 45 degrees. Okay, you must not actually derive this. You can just tell them that when theta is 45, that is when we have what we call maximum range. Maximum range is obtained when the angle of projection I will have shown us how this occur in the diagram. But whenever the angle of projection is 45 degrees, we have maximum range. Then from the formula of range, we say range. Range is u squared sine 2 theta all divided by g, right? Now if you look at it, if sine 2 theta equals to 1, what do we have here? 1 times u squared over g, which is what? So maximum range is u squared times, what do we say sine 2 theta is 1, then divided by what? G. So range maximum is simply u squared over g. Please take note that range maximum is simply u squared divided by what? G. Range maximum is simply u squared divided by what? By g. Now let's solve some problem. Please, if you are following, indicate that you are following. Connect me. Okay, there's something I want us to look at. There's another thing I want us to look at, which is called the trajectory. 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 When you hear the word trajectory, this is the path described by the projectile. This is the path. This is the path described by the what? By the projectile. This is the path described by the projectile. This is the path described by the projectile. Then there's what called trajectory equation. Trajectory equation. Let me explain something. Projectile is a body that moves, right, in the parabolic path under the influence of what? Gravity, right? In the parabolic path under the influence of what? Gravity. How then? Now look at this now. Look at this curve. This is a parabolic curve. This is also called, another name for parabolic. Parabolic is what? Is a quadratic what? Quadratic what? Curve, right? When you hear the word parabolic, it means quadratic. Then, and the general expression of quadratic equation is what? Is given as as squared plus what? Bs plus c, right, equals to what? 0. Is that not somebody? Now we can actually describe the called the part of the projectile. We can derive the equation of that projectile pathway. We can describe the equation of the projectile pathway, meaning as this body is being projected along this path, it is being projected with an equation. Are you there? So let's look at how we can describe the equation of this projectile pathway. Okay, then I wrote here, I said this is an equation that describes the path the projectile follows. It is the equation that connects x and y directly. It is a quadratic what equation. I repeat again, trajectory equation is an equation that describes the path the projectile follows. Okay, it is the equation that connects the x and y directly. The x I'm talking about here talks about the horizontal displacement, while the y talks about what the vertical what displacement. Now let's look at what we're going to achieve at the end of the day. Don't forget that we recall that displacement is what is ut plus what half at square, right? Then we said for horizontal components, we agreed that ax is equal to 0, right? Neglecting what resistance. Then we say for horizontal components, x becomes what x-axis, right? Equals to what? Yeah, we're going to have here to be ust plus what half ax t squared. So x becomes uxt plus what half times. When you increase 0 here, everything will be what ust, because 0 times t squared times half is still what 0. All right, so that means our s is simply what us represents what here u cos theta times what times our time of light. So that means our x is equals to what u cos theta times t. Let me call this equation 1. Let's describe the vertical now. I'm heading somewhere. For the vertical components, we have already done it before. I'm just repeating for the sake of those who just came in. For the vertical component, from the same expression, I will represent this x as y, right? Y is equals to what? Uyt minus. Why are we using minus? Because for the vertical, we are saying that our ay is equal to what? Minus g. Don't forget. So here becomes what? Here becomes minus half g t squared. This is equation what? This is equation 2. This is equation 2. Okay, let's finish our analysis. Uy represents what? U sine theta. So that implies that y becomes what? U sine theta times t, okay, minus half gt squared. This is equation what? 2. Minus half gt squared. Now, from equation 1, what? 1, I will make the value of our x, our t rather, to stand alone as the subject of the formula. Okay. What I'm trying to do here is to generate an equation that connects both x and y together. Okay, that connect both x and y together. So from here, I'll make my t a subject of the formula. If I should make my t a subject, it means that our t becomes what? X over u cos theta, right? Okay, we make what? T as the subject, right? Subject of the formula. If I should make t as my subject of the formula, it means that my t becomes what here? X over u cos theta. X over what? U cos what? Theta. Right? X over u cos theta. Let's call this equation 3. Now, the essence of making this as a subject is to, at the end of the day, I will replace my t. I will put this value of my t, which is my equation 1, into equation 2. So I will say put equation 3 into equation 2. Okay? By so doing, I'll be able to integrate both x and y together, right? So let's put let's put equation 3 into equation 2, meaning anywhere we see the value of t, I will replace with what? S over u cos theta. That will give us y equals to, so let's go. Here we have what here? U sine theta times, our t is what here? X, okay? X over u cos theta, right? Minus half g, okay? Our t is still what? X over u cos theta all squared. I'll repeat again. Listen, minus sign is there. I will repeat again. The first we have is S equals to u cos theta times t. We all know this from the beginning. I've already explained this. And why do we have it? Because we have a resistance that makes our AS equals to 0. Exactly? So, and that gives us this. So from here, for vertical component, we have y equals to uyt minus half gt squared. Why do we have negative? Because as the body is going vertically, okay, our ay is equals to what? Minus g, right? So, and that gives us what we have here, because our uy is u sine theta times t minus half gt squared. Exactly. Okay, so what we did next was, from equation 1, we have to make our t as the subject of the formula. And that's what we have, t equals to x over u cos theta, equation 3. Please take note of it. You might be asked to derive this in the exam. This is in your textbook. They might tell you prove or show that the parabolic, the trajectory equation is given as this. It's possible because it's in your textbook. So please take note of this. It's very important, okay? So from here, we have to put equation 3 into equation 2, meaning I'm replacing my t as this in equation 2. So anywhere we see t, I will put what? S over u cos theta. So y becomes u sin theta times t is what? What's that t here? X divided by u cos theta minus half g. What's that t again? X over u cos theta. Then we now square this because there's a square here in this expression. So that means that the value of u can go with u from here. The ratio of sine over tan over cos rather. Don't forget that sine theta over cos theta is equals to what? Tan theta. So sine over cos is simply tan. So that means my y is equals to what? Is s tan theta. Sine over cos is tan theta. Then times x. That will give us what here? S tan theta. Minus, let me come down a little. We have y equals s tan theta minus, I can expand this to be half g, this is s squared, abi, g s squared, all right, over u squared cos squared theta, u squared cos squared theta, cos squared theta. All right, I'll repeat again. Sine over cos is tan times x is s tan theta minus half g s square abi divided by u cos theta all square is what? U square cos square theta. So by the time we evaluate this further, I can actually multiply this out, and that will give us our final expression. I hope I can claim. Hope you guys are following. Hope you guys are following. Hope you guys are following. All right. I love the response I'm seeing so far. That is awesome. Thank you, guys. At least the basic has been cleared. So by the time we evaluate further, this will give us y equals to s tan theta minus g s squared divided by 2 u squared cos square theta. This is the final answer here. We can as well rearrange this. This can come first, then followed by this. Okay, this is our final answer to this problem. All right, guys. So let's look at what next. Let's solve some problems now from your textbook, so we can proceed from here. Okay, the first question I want us to look at will take us a little time because it comprises of everything we have learned so far. Almost everything we have learned. Almost everything we have learned. And I would like us to please pay attention as we are learning. The question says, is in your textbook. If you have your textbook, open your textbook, okay? For those of you who are in Imo State University, I hope I can clean this, right? Okay, the question says that a projectile is launched with a speed of 50 meter per second at an angle 40 degrees above the horizontal, ignoring the effect of air resistance. Ignoring the effect of air resistance. You should know what happened here. When they say ignoring the effect of air resistance, good. It means there is no horizontal acceleration. Then US equals to what Vx, right? Awesome. Determine, the first one says determine the maximum speed. Let me repeat the question again. A projectile is launched with a speed. The speed here is given as 50 meters per second at an angle of, our angle there is 40 degrees above the horizontal, ignoring the effect of air resistance. I won't have time to start drawing. The diagram is just the normal diagram, right? We are given our speed as 50 meters per second. Our angle is what here? 40 degrees, and so on and so forth. Please, on your own, just draw your diagram. Put in this diagram for them, okay? Put in this diagram for them. But the board is small, so I will not have enough space to put that down. Now we also find the maximum height attained by the projectile. The maximum height attained by the projectile. Now, the first thing we need to do is that I have to state, because we already told that ignoring air resistance, I'll just have to bring out some vital things here. First of all, I will say that our vertical acceleration is simply what? Minus what? 9.8 abi meter per what? Second squared. Is that clear? Okay. Then another thing that we're going to state here is that the value of our ax is simply equals to what? 0 meter per second. I hope you know why this is 0 meter per second. And also that Vx, right? That Vx is equals to what? Ux, because we are ignoring air resistance. Then the next is that I'm going to look for my Ux. Ux is U cos theta. Then also find Uy, which is what? U sin what? Sin theta. Okay? We have U cos theta and U sin what? Sin theta. Then we are asked to find the maximum height attained by the projectile. Number 2, find the horizontal range. That's number 2. Number 3 says 3I, the displacement. 4 says velocity of the projectile 2 seconds after it is launched. The next one says the time when it is 40 meters above the projection level. All right. the time when it is 40 meters above the projection level. This is very lengthy, but let's see how far we can go with it. So the first one is, let me get my calculator. Please bear with me a little. So here we are giving this to be, our speed here is 50. 50 cos 40, right? 50 cos 40. We have cos 40. Let me get the right calculator. Please bear with me. I'm coming. Okay. So we have 50 cos 40. This is about 38.30. 38.30 meter per second. Please, you can be checking that for me. Let's check together. Cos 40 times 50 times 50, 38.30, correct? Then this other one will give us 50 sine 40. 50 sine 40. This is about 32.14 meter per second. Now, we are now asked to find, the function says find the maximum height. The maximum what? Height. Already we know that maximum height is given as what? U square sine square theta over what? 2g. Maximum height is given as that. So let's input our value. Our u, initial speed, is given as what? As 50. So we have 50 all squared sine. Our angle of inclination there is 40. So sine 40 all squared. Don't forget that sine squared theta means sine 40, then we square it. Divided by what? 2 times our g here represents, we're using 9.8, right? 9.81. 9.81. That's the value there. So H max is definitely 50 square is about 2,500, right? 25 times sine 40 is about 0.6428. 0.6428 all squared. All divided by 2 times 9.8 is about 19.60. 19.60. Now let's punch our calculator to see what we're going to have at the end of the day. Yes, we have sine 40. 0.648 all squared. Square of the answer. Okay. At the end of the day, we are having 52.66 meter. So this is the maximum height. Please, if you are following, indicate in the comment section that you are following. Please indicate that you are following. Indicate that you are following. Indicate that you are following. All right, so let's write on. Okay. Now the next one is B. This part says find the horizontal range. Find the what? Horizontal range. Okay. Horizontal range, we know it's R equals to what? U square sine 2 theta all divided by g. So that will give us what here? The value of our u is 50. Thank you. We have 50 square sine 2 times theta is 40 degree. 40 degree all divided by what? 9.81. So range in this case, 50 square is 2,500. Okay, here we have sine 2 times sine 2 theta means 2 times theta. So our theta is 140. So 2 times 40 will give us sine 80, right? All divided by 9.81. So let's see what we're going to have at the end of the day. By the time we multiply out, that will give us, okay, I'm coming. Let me just ensure that. Okay, our range here becomes 250 250.97 meter. Our range is 250.97 meter. Please, if you are following, indicate that you are following in the comment section. Please indicate that you are following in the comment section. Please indicate that you are following. If you are active, if you are following, please indicate that you are following. Should we continue? Indicate that you are following. Oh, thank you, Emmanuel. Emmanuel, thank you for being active. Who again is following? Who again is those of you just coming in now? Please ensure you go back to the class. Please go back to the video. We have really gone far already. But just keep on indicating that you are following. Right? Now we have solved this. Let's continue with this. The next question. The next question says that find the displacement and velocity of the projectile after 2 seconds, right? Displacement and velocity after 2 seconds. After 2 seconds. Okay. After 2 seconds. I hope I can clean this side, right? Let's take note of this. Okay. The next question says, which is question C, displacement after 2 seconds. What does that mean? I've already analyzed something, and I want to repeat this again. For those of you who just came, displacement, we agreed is what? Is ut plus what? Half at squared. Displacement is a vector quantity. That means after solving for x and y, I can represent them in vector form before finding the displacement after 2 seconds. Are you guys following? Let me explain what I mean by that. For x, we say x is what? Is u cos theta, right? Times what? Times t. Because here AS is equal to what? 0. Don't forget that if I'm looking for displacement along the x-axis, our AS is 0, right? So our S becomes what? S cos theta. Is that clear? So the first thing we need to find first is displacement along the x-axis, right? But recall that displacement along the x-axis is simply u cos theta times what? T. So our x becomes, we have already gotten the value of u cos theta. What do we solve as u cos theta? In the comment section, please check for me. What do we solve as u cos theta? Again, that should be 38.30. I hope you guys understand what happened here. From what we just said, yeah? From x equals to what? Ut plus what? Half what? At squared. So our x here becomes what? Ux, right? T plus what? 0, because here AS is equal to 0. Is that clear? So that means the only value we have here is simply our x equals to what? Ux times what? T. Already we have already solved our Ux as, from the beginning we solved Ux as, I think 38.30. 38.30 times our time is 2. We are told after 2 seconds. So when you multiply 38.3 by 2, that will give us about 76.60 meter. Okay. Now, we say displacement after 2 seconds. We're going to find the horizontal displacement and find the vertical displacement. Then we put both the horizontal displacement and the vertical displacement in vector form, because displacement is a vector quantity. Then when you put them in vector form, you can now find the resultant of that displacement after 2 seconds. Now, already we have gotten our displacement along the x-axis after what? 2 seconds. Now, also recall that vertical displacement, please, what do you think that will now be? From our formula, S equals to ut plus half at squared. What will it be here? Y equals to what? Uyt minus half, right? Gt squared. Don't forget that under vertical displacement, we say that our AY, right, is equals to what? Minus G. For those just coming, go back to the class. I can't go back to a lot of things. I've given the fundamentals, the fundamental assumptions under projectile. And one of them is that vertical acceleration is equals to minus G, which is what I just stated here. As the body is being projected, AY is equal to minus G. So I won't go back to that again. So here we have recalled that y is equal to UYT minus what? Half GT squared. So we can find the value of our y as UY, we have already solved UY as 32.14. Please confirm from your notes. UY is what? 32.14. 32.14. Okay. Times our T is 2. Don't forget. The minus half times 9.81 times, we are told after what seconds? 2 seconds. Here becomes 2 squared. Here becomes what? 2 squared. So the value of our y becomes what here? Y becomes 32.14 times 2. 32.14 times 2 will give us about 64.28. 64.28 minus, let's see what we're going to have here. When you evaluate this, 2 squared is 4. 2 squared is 4. 2 times 2. 2 squared is 4. Sorry, excuse me, guys. Give me some time. We have 2 squared, which is 4, times 9.81. That will give us 39.24. Divided by 2 will give us about 19.62. 19.62. So by the time we subtract these two factors from each other, we're going to have our y as 12.52. 12.52 in meter. 12.52 in meter. So the next thing is to represent our displacement. To represent our displacement in vector form. Please always do this in the exam. Represent displacement in vector form. So displacement in vector form. Okay, we then become our displacement, which is our x, is equals to square or equals to SI plus YJ, right? SI plus YJ. X represents I. If you're looking at the S as represent what? I components. Y will represent what? J what? Components. So I can represent that this way. So that means my displacement equals to our F is 38. So 76.60I plus our Y is simply 12.52J. Then the displacement after 2 seconds will then be, the modulus of displacement will now be square root of 76.60 all squared. Don't forget that if in vector form, for those of you who are just coming, if today is your first time joining us, let me see what I can do to explain that. If we are giving this in vector, that vector A equals to SI plus YJ. To find the resultant or modulus of A is simply square root of S squared plus what? Y squared. So the S component here is what? 76.0. Why the Y component is what? 12.52. That means my displacement then becomes what? Square root of, this formula will now apply, right? Now give us 76.60 all squared plus 12.52 all squared. By the time we find this, modulus of this, that will give us about 88.66 what? Meter. 88.66 meter. This is our result for this. Please, if you are following, please indicate that you are following. Indicate that you are following. If you are following, indicate that you are following. Indicate that you are following. All right. I've always thought it as something. When it comes to vectors, like displacement, right? Displacement is a vector quantity that has size and what direction. Okay. No vector is fully described without talking about their direction. So I can find the direction of this vector. My direction. Look at this. This vector here, I and J, falls in the first quadrant, right? Falls in what quadrant? The first quadrant. Is that clear? I want to describe the direction now. The direction of this displacement. This is the magnitude. Displacement is a vector that has size and direction. This is the size of the displacement. Let's analyze the direction of this same displacement. But to analyze it, I must have to use what? My vector. This vector shows what? Positive what? It shows positive x and positive what? Y. So that means if you fall in the first quadrant that says x is positive, right? Y is what here? Positive. Then the angle here is called what? Our angle theta. So our y component here is simply 12.52. Our x component here is simply what? 76.60. So because this falls in the first quadrant, that implies that we can actually use any of the three to find the value of our angle, right? We can either use sine, cosine, or tangent. So using tan theta. The word tan theta is from the word tua, which is opposite of our what? Adjacent. Meaning my opposite is 12.52 divided by what? 76.60. So let's find the value of this together. We have 12.52 divided by 76.60. Okay. The answer. Sorry. Pardon me. We have 12.52 divided by 76.6. Then we'll find shift and tan inverse of this answer. This is about 9 points. Our angle here is what? About 9.28 degree. 9.28 degree. That is our direction. Please, if you are following, indicate from the comment section that you are following. Please indicate. If you are following, please indicate that you are following. Hello guys, indicate. Anita, Ndubeze. So the y component for the statement is equal to 44.66. Are you kidding me? I think there's a mistake in our calculation somewhere. I'm so sorry for that. Okay, what is the value there? We got our x, right, to be 76.60. Sorry. Let's confirm that of our y. Y is u yt minus half gt squared again. So y becomes what? Our uy should be, okay, let me confirm again, please. 32.14 times 2 minus half times 9.81 times 2 squared, right? This will give us about, okay, we say here is about 64.28 minus 2 squared times 9.81 divided by 2 is 19.62. Okay, we did not, did we subtract that? Okay, the result here is 44. Thank you for the observation, 0.66 meter. Thank you for that observation. Thank you for that observation. Thank you. So we're meant to use here as 44, right? 44.66 J. So here we will now be what here? Let's go again. We're going to have 44.66 all squared. 44.66 all squared. Is that clear? Okay. 44.66 all squared. All right. So 76.60 squared plus 44.66 squared. Let's verify again. Let's verify. Okay. Square root of that. Okay. The result is still 88.66 meter. Okay. This is the result. Our answer is still 88.66. So we just made a little error here. So please correct that. Thank you for that observation. That means you are following. Please, let's keep on. Thank you so much, Anita Ndubeze. I'm so grateful for that observation. That shows that you are following and you are active. I'm really grateful. I have a reward for you. I have a prize for you. Okay, thank you for that observation. Okay, now we have gotten our displacement, but I think this value here will affect our direction. It's going to affect our direction. Please take note of this. Okay, it will affect our direction. I guess so. It will surely affect it. So let's repeat our direction again. Our direction. See here, it still falls in the first quadrant, right? That shows that here we have our theta. The y component here is 40 what? 44.66. The s component here is 76 point what? 60. So using our tan theta equals 44.6 divided by what? 76.6. And that will give us, let's finish up this again. Thank you so much. This is a huge mistake. I think that should be error of omission. So sorry for that error. Let's calculate our angle again. 44.6 divided by 76.6. 44 opposite over adjacent. Okay, divided by 70.6. That will give us about 0. This is about 0.5822, right? Then we have shift and tan inverse of the result. Will give us about 30. Our angle here is actually 30 degree, 30.21. 30.21 what? Degree. This is our direction. Thank you for that. Please correct this now. Correct. I'm so grateful for you. To you, Anita, thank you so much. Now let's move on to the next part. The next part says that we should find our velocity. We have gotten our displacement. The next is to find velocity. The next is to find our velocity. That's the next. Okay, now let's watch. velocity after or at 2 seconds, right? At 2 seconds. Velocity at 2 seconds. The same thing we did. We're going to represent our velocity in this form. V equals to VSI plus what? VYJ. So that means our V then becomes what? Square root of what? VSI plus what? VYJ. Okay, let's look at it. What is our Vx? Let's find our Vs. Don't forget that neglecting a resistance, Vs is equal to what here? Ux. So that means that the value of our Us is also same as the value of what? Our Vs. Us and Us are the same. So Us is 38.3, right? Okay, 38.3. 38 point what? 0.3 meter per watt second. So whenever we neglect a resistance, that means our velocity is constant. Our velocity along the x-axis is constant. Our speed is constant, right? Our speed is constant whenever we ignore a resistance. But let's analyze our Vy. Vy from V equals to what? U plus what? AT. Now give us what here? Vy equals to Uy minus what? GT. Don't forget that our AY is equal to what? Minus G, right? So here becomes what? Vy equals our Uy here is what? U sine theta minus GT. So that means the right expression to use here is simply U. Okay, let me put the value here. Uy minus what? Minus GT. So let's put in our value. Uy then becomes 32 points. Our Uy we have already solved initially. Uy we have already solved as 32 points. I guess it's 114. So Uy is 32.14 minus 9.8 times 2. 9.8 times 2. When you evaluate this together, 32.14 minus 9.8 times 2, this will give us about 12.52. 12.52 meter per watt seconds, right? About 12.52 meter per second. Please verify this for me also. Verify. If the values are correct, verify. If the values are correct, please verify. Now the next is that recall that V equals to square root of what? VSI plus what? VYJ. So our velocity then becomes what? Square root of our Vx is equal to Us, which is 38.30 all squared plus V1 is 12.52. 12.52 all squared. So the value of our V then becomes what? Square root of, or rather, everything after evaluation already, that will give us about 40.29 meters per second. Please see what you do for me. Evaluate for me. Do for 38.30 squared. Then add it with 12.52 squared. Then find the total square root. The result should be this, about 40.29. Now the next is to find the direction, right? The direction. Don't forget that the direction, we have to analyze this. Our speed, our value of our speed is, okay, let's bring out the vectors first. I will have just indicated the vector here, right? The vector form is simply VSI plus what? VYJ, which will give us what? Our VS is 38.30, 38.30I plus our VY is 12.52. 12.52 what? J. Is that clear? So by the time we solve further, our direction shows that both of them both x and y are along the what? In the first quadrant. They are both positive. So that means that we can just construct something like this, indicating that both of them are found where? Along the y-axis, which is 12 point what here? 52 for y. S is 38 point what? 3. Is that clear? 38.3. Then we have our angle of what? Inclination. Then our theta. So from here we can find our tan theta. We can also use sine, of course, because the value of our speed falls in the first quadrant. That since all is positive. So sine can work, cosine can work, tangent can also work. But let's do this over tan. That will give us 12.52 divided by 38.30. Alright. 12.52 divided by 38.30. Then we have shift and tan, inverse of that answer. That will give us about our theta here is equals to about 13.10 degree. So when you divide that value, then find the tan inverse of that value. That will give us about 18.10. The equation is very long. It's in your textbook. Someone is saying this question is very long. That's why I have to solve this. It's taking us time, Abby. It is well. I'm almost done. So we are done with this. But the last part of this question, says that we should find the time it is 40 meters above projection level. Find the time. The last part, which is D. Find the time. It is what? 40 meters above the projection level. Okay? Projection what? Level. Projection level. Find the time it is 40 meters above the projection level. This is very simple. What we need to do is, since we are dealing with heights now, right? We are giving our y to be 40 meters in this case. Formula says x equals to ut plus what? Half gt squared. Exactly. So my x becomes what here? Y equals to what? uyt minus half what? gt squared. So my value of y is 40 equals to our uy. What is our uy again? Let's put our value. We have 32.140 minus half times 9.81 t squared. So we have 40 equals to 32.14 t. Let's divide 9.81 by 2. This will give us about minus 4.905 t squared, right? Okay, t squared. Now the next thing is for us to rearrange this. If you look at this, is already looking at a quadratic equation. Let's move all the terms. Let's move all these terms to this other side, right? Okay, or let's rearrange the term. I can rearrange it to be minus 4.905 t squared, right? Plus 32.140, okay, equals to what? 40. Is that clear? Equal to 40. I only rearrange this, so I can move this 40 inside, and that'll give us what here? 4.905 t squared plus 32.140 minus 40, all equals to what? 0. Okay, here we have minus sign here. Then I will look for a mean because this is already a quadratic equation. So what we do next is to divide through by what? By minus. That will give us 4.905 t squared minus 32.14 t, right? Plus what? 40 equals to what? 0. Now the next is to solve for what? For the value of t, because it's a find time. So this is very lengthy. I might not continue with this. I will just give an assignment. So this is your assignment here. On this, we have here to be 4.905 t squared minus what? 32.140 plus 40 equals 0. Use formula method, quadratic formula method, okay, to find the value. Formula says what? It says t, right, equals to what? T equals to minus b, right? T equals to minus b plus or minus square root of what? B squared minus 4ac, all divided by what? 2a. Use this quadratic formula to solve for this. From here, you know better. Our a is what? 4.905, right? Our b is what? Minus 32.14. Then our c is what? Is 40. So put in, let me repeat again. A is equals to what? 4.905. B is equals to minus 32.14. Then C is equals to 40. Put in these values here. Then at the end of the day, you have your value of t as your value of t will either come out as either 1.67 or t equals to 4.88 seconds. Please do this for me as your assignment, because this is very lengthy. So we can go into another example. All right. Once you are done solving this and you have solved this, please send in your answer on my WhatsApp. My WhatsApp number is 09063111961. Okay. Already I've given you the formula already to solve for the value of t. Just put in the value and solve for what? For t. This is your assignment. Next question. 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 We can't dwell on one question like that. It's not possible. This will not take me. It won't take our entire time. Okay. Let's focus on something else. Okay, the next question we have here in your textbook. Next question we have here. Let's analyze the question together. The question says that a board is projected horizontally from the top of a vertical cliff. A board is projected horizontally from the top of a vertical cliff, 40 meters high. The height of the cliff is 40 meters. This is physics. The height of the cliff is what? 40 meters. With a velocity of 20 meters per second. Our velocity here is 20 meters per second. This velocity is called US, which is what? 20 meters per second. How do we know it's US? Because we are told that a ball is projected horizontally. So the horizontal speed was given as 20 meters per second. Then the question says calculate the time to get to the ground. Calculate the time to get to the ground. Number 2 says find the vertical component of the velocity at the ground. Number 3 says find the distance from the cliff when it strikes the ground. The next one says find the resultant velocity when it strikes the ground. Okay, let's solve together. Let's bring out our points. Height was given as 40 meters. A board A body is being projected horizontally from the top of a cliff, right? We are told that our US is 20 meters per second, right? Our, what again? Our height is what? Is given as what? 40 meter, okay? Our G is given as 10 meter. They say take G as 10 meter per second squared. Now listen, whenever a body is projected horizontally, that means that at this point here, our UY is equals to what? 0. When a body is moving horizontally, that means the vertical initial speed is what? Is 0. Because at that moment, the body only has what? Horizontal what? Velocity. So UY is 0. Are you there? Now, we are now also find the time to get to the ground. The first one says find the time to get to the ground. The time to get to the what? To the ground. Let's repeat this question again from beginning. A ball is projected horizontally from the top. It is the cliff here. From the top of a cliff. It's being projected horizontally from the top of a cliff. Okay? With an initial speed, our US is given as what? 20 meters per what? Second. Are you there? This is the speed of the what? Of the ball. Right? From the top of a cliff. The height of the cliff is what? Is 40 meters. So since the ball is projected horizontally, the ball is not moving vertically. It means our UY is all is 0 because we projected the body along the what? Along the x-axis. Is that clear? Okay, with the velocity of that, then we have to find the time to get to the ground. Look at this now. This is very simple. Recall that height is equals to what? UT plus what? Half GT squared. UT plus half GT squared. This question here you are looking at now. Here we are using the equation of force of motion under gravity to solve this. This is not just like a body projected upward, where we say that our AS is 0, right? And all that. But for this, the body is projected from the top of a cliff. So the body is falling towards what? The earth. Are you there, somebody? So as the body is falling towards the earth, what will say happen? UY is what? 0 because the body is moving horizontally. At this point here, our UY is 0. In secondary school, they will tell us when the body is falling towards the earth, your U is what? 0. The same concept here. If U is 0, that means this value is what? Is 0. So since I'm dealing with height, I'm dealing with height, then here will be what? Here will be my Y, right? Let me change this to what? To Y. Y is 40 meters. So Y equals to what? UYT plus what? Half GT squared. Why do we use plus sign here? The reason why we use plus sign because at this point the body is falling from the top of a cliff towards the earth. The body is not projected. When the body is being projected, okay, what do we say happen? The acceleration is constant, right? And the body is always directed towards what? The earth. I repeat again, when the body is projected from the floor, from the ground floor, release. At this point, as the body is going upward, we say that AY is equals to what? Minus G. But for this diagram here, the body is not projected from the ground floor. The body is projected from the top of a cliff. So I mean, the body is falling. It simply means that our G is what here is positive. Are you there? Under free fall, if a body is falling towards the earth, G is always what? Positive. U is what? 0. Then when the body is going up, G is what? Negative. V is what? V is 0 under free fall. This is a good example of what? Of a free fall. But because we say the projectile from the top of a cliff, and we are told that is being projected horizontally. So that means there is no vertical what initial speed. So my uy is 0. So the point where the body falls, we are saying that uy is what is 0. But because the body is falling freely, it means our g is what positive. So from this expression, our y is already given as what? As 40, right? Y is 40 equals to what? Uy is 0. Don't forget that uy is 0 because the body is only moving horizontally. So 40 equals to what? 0 times t plus what? Half times 9.8, right? 9.8 times what? T squared. So we have 40 equals to 0 times t is 0. 9.8 divided by 2, that will give us about, okay, we are told that g is 10. Thank you. Okay, someone just commented. G, we have g as 10. Here we have 10 half 10 t squared. So that means that 2 here 1, 2 in 10 will give us what? 5, right? And that will give us what here? 5 t squared. Is that clear? So the next is to divide. Divide both sides by what? By 5, because our aim is to find t. So divide by 5. 5 here will cancel, 5 will cancel. That implies that our t squared, 5 here is 1, 5 in 40 is about 8, right? So t squared equals to what? Equals to 8. Equals to 8. By the time we evaluate, sorry, t squared equals to what? 8. Therefore, our t equals to square root of 8. This is about 2.83. 2.83. Let me repeat what I just said again. Time to get to the ground, because the body is projected from the towards US. It means that my vertical speed uy is, all right. If that should happen, that implies that t equals to what? 0 times t plus half times our g is what? 10 t squared. 2 here is 1, 2 in 10 is 1 is 5. Then when we solve further, we have t as 2.83. Please, if you are following, indicate from the comment section that you are following. Please indicate. If you are following, please indicate. Are you guys still following? Indicate. Okay. Now the next question says that we should find the vertical components of velocity. Vertical components of what? Velocity. Find the vertical component of velocity. Find the vertical component of what? Velocity. Vertical components of our velocity. Number 2 says, find the vertical component of what? Velocity. Not uy. Uy is also vertical, but uy represents what? Initial vertical velocity, right? But in this case here, we are looking for the final. Recall that v equals to what? U plus 80. Is that clear? So here I'm going to use u plus gt. Why is it gt? Because the body is falling towards the earth. Is that clear? Motion under gravity, we use plus or minus. Is that clear? But because the body is falling, I will take what? The positive sign. Okay, so let's move on. Here becomes what? Vy equals to what? Uy plus what? Gt. So let's go. We have Vy then becomes equals to what? Our Uy is 0 because the body is only moving horizontally. So initial particle velocity is equals to 0 plus our G is 10 times our T. We have already solved our T to be about 2.83, right? 2.83. By the time we evaluate it further, Vy equals to what? 0 plus 10 times 2.83 will give us about 28.3 meter per watt second. This is our particle components of velocity. The next question says find the distance from the cliff Find the distance from the cliffs. Find the distance from the cliffs. Find the distance from the cliffs. The distance from the cliffs simply means find the range. Find the range. RS. Range simply means distance. Horizontal distance, right? Okay. To find the distance, we use our RS equals to what? US times what? Time of flight. Time of flight, or UST. In this case, our T, we already solved for our T, right? As about 2.83. Is that clear? That was the first question we solved. The first question says find the time to get to the ground, and that time we solved is about 2.83. Exactly. So that means my ROS becomes our US is 20. US is given as 20 times about 2.83. So range ROS becomes multiply this for me. 20 times 2.83 will give me 56.6. 56.6 what? Meter. 56.6 what? Meter. Then the next one says find the resultant velocity. Please, if you are following, please indicate in the comment section that you are following. Please indicate that you are following in the comment section. Someone said the camera is cracking.
Is the camera clear now? Is the camera clear now? Okay, the next question says find the resultant velocity. Find the resultant what? Velocity. Let's solve for the resultant velocity. Let me use that. To find the resultant velocity, I'm sorry, I have to remove my what's it called? My microphone to charge the phone a little. Alright, so please, very soon I'll put back the microphone. Okay? Pause. Please just bear with me with the sound. I know the sound is not clear, right? To find the resultant velocity, give me some minutes. To find the resultant velocity, okay, we have to represent our velocity first in vector form, Abi, which is equals to what? Vsi plus what? Vyj. Already we have already solved. We know that. Recall, don't forget that at all time in projectile, the first assumption is that whenever we ignore a resistance, that Vs must be equal to what? Ux, right? Our Us is given as 20 meters per second. That means that my Vs, which is also what? Us is equal to what? 20 meters per second. Do we have our Vy? Yes, our Vy is 28.3. Vy is 28.13. Therefore, our velocity in vector form becomes what? 20I plus what? 28.3 what? J. So to find the resultant velocity, that will give us square root of what? 20 all squared plus what? 28.3 all what? All squared. Okay, now let's evaluate further. By the time we evaluate further, what do we have? Let's evaluate further. Please, someone should check for me in the comment section. What is our velocity? Square of 20 is 400. Then this is about 28.3 squared. Let's verify. 28 points. 3 all squared is about 28 points. Is that 28.3? 28.83, sorry, 28.83. This 83. 28 point what? 83. Let's evaluate together. 28.83. 28.83 all square is about 831.1689. When you add up this with this and find the total square root, the result become 34.64. 34 point what? 64 meter per what? Second. 34.64 meter per second. Hope we understand what happened here, right? We have to find the resultant velocity, meaning the resultant, we have to bring out the vector form. Our Vs is what? 28.83, not 3. 28 point what? 83. Okay, which is also same as constituency with 2 or what? Then 28.83 is our Vy. Then our Vx, our Us is 20 meters per second. But because we are ignoring errors distance, Vx equals to what? Ux, right? And that gives us 34.64 meters per second. Now let's see one more example. Coming. Let's solve one more example. Okay, 800.89. Alright, please check for me. Check. What is 20 squared plus 28.83 squared? Then find the total square root of that value there. Check. Before we continue to the next question, please check for me. Alright, next question from our list here. Next question. Please, if you have any question from your past question, do me a favor, just go to the past question, IMSO past question. Pick out any question from the past question. Just type it in the comment section. Type it for me in the comment section. Go to the past question now. Any question you don't understand from the past question, type it for me. Let's solve it together. Are you there, somebody? So please go to the past question. Go to the past question. Go to it. Let's solve together. I have a question here that says that an object is projected upward at an angle 30 degrees to the horizontal from the top of a tower of height 100 meters. The height of the tower is 100 meters. An object is projected upward at an angle. The angle of projection is 30 what? Degree. To the horizontal from the top of a tower of height 100 meters. And it hits the ground at a point Q. If the initial velocity of projection is 100 meters per second, initial velocity of projection U is 100 meters per second. Okay? Calculate question 1. Says maximum height. Maximum height. Number 2 says time of flight. Time of what? Flight. Number 3 says horizontal distance, which is our range from the foot of the tower to the point Q. This is very simple here. Let me just show us this diagram briefly. We are told that an object is projected upward at an angle 30 degrees to the horizontal from the top of a tower. This is the tower here. The tower height is given as 100 meters. So the body is being projected, from the top of this tower. It's projected this way towards what? The earth. Right? At a certain angle. And the angle of projection there is given as 30 what? Degree. And we are told that the speed of projection, the speed here is 100 meters per second. Okay. Then we are also told that, and it is the ground at a point Q. That means this body landed and hit the ground at point what? Q. This is the ground floor here. There's the height here, right? This is the highest vertical distance attained from this point here. Let's call it point A, point B, point C, point D, point let's see point D. Let's put another point here. Let's call it point D and point E. Okay? Let us put some point and all that. The ball is projected from the top of this tower here at an angle theta. From here, the body gets to this point, right? And the body returns back to the earth. It returns back to the earth. Don't forget, it returns back to the earth. Now we are now asked to find the maximum height. Maximum height here, we are told that the height of the tower is 100. To find the maximum height, the highest vertical distance attained is no longer here because we are dealing with what? A tower. It means that to find the maximum height, I have to find this height first, from D to what? To B. Is that clear? From D to B. I'll find this height here. When you get this height, then add up this height with this other height. That will give us what? Our maximum what? Height. Okay, so let's go. Maximum height. Maximum height, H max, is going to be, let's call here HBD. HBD plus HD. Okay, this is, let's put letter G here. G and Q. Alright? So H max is this height plus this height. Already we know height as what? 100, because if this height of the tower is 100, this is also what? 100, right? This 100. This also what? 100. But we don't know this height here. We don't know this height. Let's find this height, this BD. So to find height, formula for finding maximum height for this kind of diagram, I give us the diagram, general diagram for projectile. This is the maximum height, abi H max. I would say H max is equals to what? U squared sine squared theta divided by what? 2g. So the first thing I will need to find the maximum height, this height here, with this formula, right? And that will give us what? At the end of the day, let's verify what we have here. Let's find our HBD. HBD, meaning this height here, is simply equals to what? U squared sine squared theta divided by what here? 2g. So that will give us our HBD equals to what? Our U is 100. 100 squared sine. Our theta is 30. Sine 30 all what? All squared. Divided by what are we given as G? G is 9.81. We are told that G is 9.81 meter per second square. So that means 2 times 9.81. So HBD then becomes what? 100 square is 100 times 100. And that will give us what? Let's calculate with our calculator and see what we're going to have at the end of the day. Please excuse me. Here we have sine 30 square is 0.5. This is 0.25. So we have 100 squared. Here we have 10,000 and 0.25 divided by 0.81 times 2. Is about 19.62. Let's find the total answer here. 10,000 times 0.25 divided by 19.62. This is about HBT is about 127.42 meter. So our HBT is 127.42. Okay, correct. But maximum height is simply HBD plus what? HDG, meaning our HBD, this height plus this height. Already we have got this height, right, as 127. So we have 127 plus our HDG or HAE. That will give us 127.42 plus 100 will give us about 227.42 meter. This is our maximum height. Please, if you are following, please indicate from the comment section that you are following. Please, if you are following, indicate from the comment section that you are following. If you are following, please indicate that you are following. The next question says we should find the time of light. The time of light. Time of light. I would love to clear here, so please glance through this. Glance through. Please take note of this. Time of light. Next question says, find the time of light. Time of light. Time of light. Okay, let's find the time of light. Please, if you have not shared this link, please share. We are still learning. I'm still teaching, and this class will continue. I will solve more examples. If your data is finished, you can just leave it. Then any other time you come online, you can always go through this. I want to exhaust everything under Projectile today. Every single thing. I have a lot of examples to solve. Up to 5 to 6 examples. Although I might not exhaust everything, but at least to some extent, so that you'll be able to solve some problems by yourself. Are you there? So that's why I'm taking my time to explain this. Okay? So please, let's keep on sharing. If you have shared the link, indicate in the comment section that you have shared it. Please indicate. If you have shared, indicate. indicate. If you have shared the link, please indicate in the comment section. Very important. Please, if you have shared it, indicate. If you have shared it, indicate in the comment section. Number 2 says, find the time of flight. Many of you will fail this. Many of you will think the time of flight we are referring to here is t equals to 2u sine theta over g. This is not the formula that we use. This is not the formula that we use. This formula can only be used if I have a diagram like this, right? Where there is no height. But here we have a height here. We have a tower. We have a height. So I can't say that my time of flight is this. This formula is from this point, Abi, to this point. I hope you are aware. But this diagram is saying that the body is projected from the top of this tower. And the body gets to this point and exceeded this point and returns to the earth. That means the time of flight covered from point A to point Q. But for this diagram, it's just from point A to point C, from this point to this point. To find my time of flight with this diagram, I will use this formula to solve. But for this, I can't use this to solve. I need somebody. Now, what do we do? How do we solve for the time of flight? How do we find the time of flight? Remember that I said that if we are given a diagram like this, I started by saying that to find the time of flight, I will find the time against what first? Gravity, Abi. Then time towards what? Gravity. Time against gravity is the time taken from point A to point B, meaning time to reach the greatest height. It's called time against gravity. Gravity is influence on the body from point A to what? To point B. Gravity is also from point B to what to C, right? Because from point A to B, the body is moving against gravity. Then from point B to C, the body is moving towards gravity. So what we do is to find the time the body moves against gravity and the time the body moves towards what? Gravity. Then for this diagram here, if the body is projected from point A and the body returns to the ground to point Q, that means that I will first of all find the time the body takes to move against gravity, like we did here. From point A to point B, the body moves against gravity, right? Then from point B, the body moves towards what? Gravity. Am I communicating here? Now let's solve together. So the first thing I need to do first is to find my time to move from point A to B, which is time to reach the greatest height. The formula says T equals to what? U sine Abi theta over what? G. Then once we are done with this time here from point A to point B, the next time I will now find is the time to move from point B to what? To point Q. Using the equations of what? Of motion. Okay? But let's see. What do we have at the end of the day? Is that time of flight will then be our capital T equals to what? T from here to here is TAB plus TBQ. Now let's find TAB. TAB means time against gravity. What we say is that time against gravity is simply U sine theta divided by G. And that will give us what? TAB equals, our U is 100, sine theta is 30, divided by G is taken as 9.81. Let's check what we have here. Let's check together. Think sign 30 is 0.5, so 50 divided by 9.8. 50 divided by 9.81 will give us, let's check. Our speed is 100 here. So 30, yeah, that's 100. Okay, 50 divided by u sin theta over g. Our speed is 100. Let's confirm again. This value. Okay, let's face it like that. Divided by 9.81, right? Okay, 5.09. Yeah, we are correct. TAB is 5.097 seconds, right? 5.097 seconds. Now we have gotten our TAB. The next thing is now to find the time taken from B towards to C to Q. Okay, with the time, let's find our TBQ. Okay, please take note of this before I claim. Take note. Please, if you are following, indicate that you are following. Indicate that you are following. If you have shared it, please keep on sharing, okay? Let's reach out to other people. Please glance. I want to clean the board. Glance through it. Glance through. Glance through. Glance through. Please glance through. Glance through. Glance through. Okay, so let's finish up. Let's finish up. Now the next is to find TBQ. TBQ started from this point. Don't forget. From this point, I will explain something here before, that our Vy is equals to 0. Not just only Vy equals to 0. Uy is also equals to 0. Or from the equation of motion under free fall, when the body is falling freely, the body is falling, the value of our u is 0. Uy is equals to 0 as the body is falling from this point here. But the right way to explain this is that at this point, where the body, before the body turns, the body only moves with horizontal speed. Don't forget that at this point here, the body only moves with what? Horizontal. So all the vertical velocity are equals to 0. So Uy is part of them, and that is equals to 0. So let's move on. Let's finish up. Let me clear this part. We have already solved our TBQ. I will use height equals ut plus what? Ut plus or minus half gt squared. In this kind of equation, the body is being projected. We are considering from this point downward, right? Downward. So from the body, from this point downward, the body is moving towards the earth, meaning it's obeying the law of gravity. So G must be taken as what? Positive, right? G must be positive. Our G is positive. So, but don't forget that this speed here is our Uy, because we are dealing with what here? Vertical, right? Vertical. Then we have our speed here, which is our Uy, all right? But take note that Uy is equals to 0. Why do we say Uy is 0? Because at this point, the body is only moving horizontally. Before the body moves towards the earth, at this point, we only have horizontal speed. There's no vertical speed. So Uy is 0, all right? So if Uy is 0, that means, and our height, the height covered from this point to this point the height, we calculated the height as, I guess, 270 something point something. Our height, our total height, we calculated about 227.5, right? 227.5, right? Equals to what? 0 times t plus half 9.81 t squared. Now let's find the value of our t here. Let's find the value of our t. So we have here to be 227.5 equals 0 times t is 0. 9.81 divided by 2. That will give us about 9.81 divided by 2 is 4.905 t squared. So we're going to divide this now. To find t squared, we divide both sides by what? 4.905. 4.905. This can go with this. We are left to what? T squared equals to 227.5 divided by 4.905. This will give us about 46.3812. The square root of this answer, our t, will give us square root of 46.3812. Our t becomes 6.810. But this t here is our TBQ because the body moved from point B to Q. Therefore, TBQ is about 6.81 what? Seconds. 6.81 seconds. 6.81 seconds. Okay. Now, what's the next thing? Is to add up. Is to add up the 2 times. Abi? Is to add up the 2 times. Therefore, our time becomes the first time we have. Let's look at the first time. Please, I've already cleaned the board already. What's our first time? That should be about 5.0. Please verify for me. 5.097 plus. Here we have 6.810, right? So let's add up the 2 times. Our answer, our time of flight is about 11.91 seconds. 11.91 what? Seconds. 11.91 seconds. The last part, the last question then says that we should also find the horizontal distance. The last part says find the horizontal distance. Horizontal distance, meaning find your range, right? Range equals to what? US times t. Don't forget, US times t. For this diagram, we cannot use our normal formula for range, which is US, u squared sine 2 theta divided by what? 2g. I can't solve with this formula because I have a height. So the best formula, the general formula I can use is this. So my range is equals to u cos theta times t. So our range becomes, our u is 100 cos 30 times our time of flight is 11.91. 11.91. By the time we evaluate this, our answer become, let me just put the answer direct from the textbook. It becomes about 1031 meter. Please take note of this. 1031 meter. This question might likely appear in your exam. Please take notes. Take note of this, okay? This is similar to one of your past questions that they gave. Was it 2 years ago or 3 years ago? That a body is projected from Imo State building. And they gave us the height, and we're given the speed of the body, and we have to find all of these parameters. They are all the same, all right? So do me a favor, go through your past questions. look for that question on projectile that have to do with IMSU Senate building. Solve it and send the answer to me on my WhatsApp page. Let's look for one more example we can tackle. So please, if you're online, indicate that you're online. Indicate. Yes, someone said T can also be gotten as square root of 2h divided by g. You are correct. The same formula can also be used. If you use that formula, you will get the same answer. Okay, you have 6.81. That is good. Your other time is 4.905. Are you sure? Check your value again. It can be 4.905. Please check. It can be 4.0. No, it can't be that. Please verify again. Let's solve more example. Please, if you are following, please indicate that I am following. Don't be tired of learning. Next question I want us to look at tonight. Next question. From your textbook, the question says that what is the angle of projection? What is the angle of projection? Let me bring this question. What is the angle of projection when horizontal range equals maximum height What is the angle of projection when horizontal range equals what? Maximum height. So this question came out in your past question. We are told that what is theta, right? But we are given that horizontal range is equals to what? Maximum what? Height. Recall, what is theta when these two are equal? Recall that ROS. What's the ROS? ROS is given as u squared sine 2 theta divided by what? G. H max is given as u squared sine square theta divided by what? 2g. What we do is to equate both of them. That means what? Since we are told that if RS equals to H mass, what is theta? So let's do together. That will give us, we have here u squared sine 2 theta divided by what? G. All equals to what? U squared sine square theta divided by what? 2g. Alright. This is our range. This is what? Our maximum height. From here, u square can cancel u square, right? Okay. Can cancel u squared. Here, g can cancel g from here. We are left with what here? We are left with sine 2 theta. Alright. which is equal to sine square theta over what? G. Over 2. Over 2. I repeat again. When if u square cancel u square and g cancel g, here we are left with what? Sine 2 theta. Here we are left with sine square theta over 2. From here I can cross multiply this. By the time we cross multiply, this will give us what here? 2 sine 2 theta equals to what? Sine square what? Theta. Don't forget that after cancelling, if we cancel u square with u square, g cancel g, we are left with this. Then by the time we cross multiply this, we are going to have 2 sine 2 theta equals to what? Sine square theta. Now the next thing is to evaluate this. This is a double angle. I will look for a means to simplify this. Let me quickly run through something. Listen, please. In double angle formula, if I have sine A plus B, the expression says sine A cos B, right? Plus sine B cos what? Cos A. Are you there? For double what? Angle. A is equals to B. Double means 2 theta. Like, what will I do to this to convert this to double angle? Is either by making A equals to B or B equals to A. If A equals to B, that means anywhere I see B, I can put A or B. That means what here? Sine A plus what? A. I'm replacing my B with A, and that will give us sine A cos A plus what? Sine A cos what? Cos A. So sine A plus A will give us sine what? Sine 2A, which is equals to sine A cos A, sine A cos A. They are like terms, abi? So I can add them up, and that will give us 2 sine A cos A. If A represents theta, what will it be? Sine 2 theta equals to what? 2 sine theta cos what? Cos theta. That means the identity for double angle for sine 2 theta is simply what? 2 sine theta cos theta. So that means I can replace this man, this expression here, with this value. So that means this becomes 2 in bracket. What is sine 2 theta? Is what? Is 2 sine theta cos theta. All equals to what? Sine what? Sine square theta. I have to show us. I don't want to just start saying or start giving you that sine 2 theta equals to 2 sine theta cos theta. You will get confused. I have to show us a little proof to it. So take note of this, that double angle for sine is 2 sine theta cos theta. So by the time we put this value here, let's see what we are going to have. So I can clean up this, right? Okay, please take note of this. Take notes, take notes, take notes. Let me take out this. By the time we evaluate, 2 times 2 will give us 4. 4 sine theta cos theta equals to what? Sine square theta. From here, one of these sine, we cancel one of these sine from here. Sine square theta means sine theta times sine theta, means sine theta in 2 places. So one of these, we cancel this from here. So that means we are left with what here? 4 cos theta equals to what? Sine what? Sine theta. The next thing is to find theta. We have to find theta. So what will I do? I will need to think of how to manipulate this to get what? My theta. Right? I have to look for a means to generate an identity that will enable us to find theta. And how do we generate that identity? Is by dividing both sides by cos theta. Do you know why? Sin theta over cos theta is equals to what? Tan what? Tan theta. So when you divide sine over cos, we have tan. That means I can say divide both sides by what? By cos theta. Because sine over cos will give me what? Tan. So that means that here becomes over what? Over sine theta. Divide both sides by sine theta. Sorry, by cos theta. By cos theta over what? Cos theta. So this can go with this. Sine theta over cos theta is simply what? Tan what? Tan theta. All equals to what? What is remaining here is what? Is 4. I can say 4.0000. 4.0000 is the same as what? 4. So my theta then becomes what? Our tan inverse, right? Of what? Of 4.000. Let's find out what the answer becomes. What is the answer? What is the tan inverse of tan theta? Tan inverse of 4 rather. What is the tan inverse of 4? The answer is 75.96. 75 point what? 96 what? Degree. So our theta is what? 75.96 degree. That is the angle of projection when maximum height equals what? Equals to range. So please take note of this. Next question says, please, I hope my voice is audible. I'm not using my mic. Hope if my voice is audible. Is it audible enough? If you are hearing me, please let me know if you are hearing. Hope you are following. Hope my voice is audible. Next question says, a ball is thrown from ground into the air with an initial speed. Initial speed is given as u equals 25I plus 20j. 25I plus 20j in meter per second. Meter per second. Are you there? Calculate the time required to reach the highest point of the trajectory. Calculate the time required to reach the highest point of the trajectory. The highest point talks about the time to reach the maximum height, which is our small letter t. Don't forget. Number 2 says the time to reach the highest point, right? The time required to return to the same level. Number 1 says the time to reach the highest point of the trajectory. 2 says the time required for the ball to return to this original level. Number 3 says how far it has traveled horizontally during this time. Take g as 10 meters per second squared. Let me correct this question. I think they made a mistake here. The question says that A ball is thrown from the ground into the air with an initial speed of this. We are given this. The first question says, find the time required to reach the highest point. That's the first question. Number 2, find the highest height. Number 2 says, find the highest height. Number 3, find the time required for the ball to return to its original level. Number 4, how far has it traveled horizontally? Let's solve this together. So the first one says, the first question says this. But before we solve, we are told that our initial speed is this. Don't forget that, recall that the vector form of this speed, AB, can also be in what form? Is uxi plus what? Uyj. Hope you are aware. This is our velocity. Is that clear? Our velocity is given as that. This is our velocity. We are told that the initial velocity is given as this, right? So what we do here is that if we have this, that implies that our ux, which is our initial velocity along the x-axis, will be what? 25 meters per second. By comparison, us is 25. So uy is simply 20 meters per what? Per second. Here we don't need the resultant velocity. Okay. Now we are asked to find, the first question says, the time to reach the highest point. The time. The time to reach the highest point. In this case, there's no angle. I will have said my time is equals to what? U sine AB theta over g. Is that clear? But this can only be used if I have angle of projection. Although I can get this. I can get this by squaring this. I will square 25 square plus 20 square. Find the square root, that will give me this, right? But I don't have my angle of projection. So there's no way I can use this to solve. But don't forget that, recall that the first equation of motion says what? That V equals what? U plus what? 80. We have V equals to U plus 80. We have Vs equals to what? Ut plus what? Half what? 80 squared. Then we have V squared equals to what? U squared plus what? 2as. I always tell students that this first time will represent the time to reach the greatest height. Once they say find the time to reach the greatest height, what should come to your mind first is what? Is this. Are you there? Should come to your mind is what? Is this. And don't forget that at the greatest height, Vy is equals to what? 0. Don't forget. I showed us, for those of you who came in late, I said that when the ball is projected this way, right? At this point here, what we have the greatest height, the value of our Vy is equals to 0, right? Please take note of that. So from here, I can, since I'm looking for time to reach the greatest height, I will convert this to what? Vertical what? Velocities, right? Already we have our Ux, we have our Uy. So here becomes Vy equals to what? What do you have here? We have our Uy. Don't forget that acceleration Ay is what? Minus g. Don't forget. For a projection of this kind, when the ball is projected vertically, is projected upward, we are saying that our Ay is what? Minus g, because gravity is constant and gravity is acting towards what? Is acting downward, right? And we say that Ay is what? Minus g, but As is 0. Don't forget. So if that is true, here becomes what? Minus what? Yeah? Minus gt. But at the maximum height, Vy is equals to what? 0. Here becomes what? 0 equals to what? Our Uy is given as 20 minus, we are told that take G as what? 10 meter per what? Second squared. Take your G as 10 meter per second squared. So that means my G becomes 10 what? Yeah, T. When you move this minus 10T to this other side, here becomes 10T equals to what? 20. To solve for T, what do? Is to divide both sides by 10. By what? By 10. 10 cancel 10. 0 cancel 0. Therefore, our time to reach the greatest height is 2 what? 2 seconds. The time to reach the greatest height is what? Is 2 seconds. Number 2 says, find the highest height. The highest height. The highest height is this height here, right? The highest height is where? Is this height here, from here to here. This is our highest height. But how do we find the highest height? We don't have our angle. So I will still use my equation of motion that says height equals to what? Ut, right? Plus what? Plus, sorry, S rather. S equals to what? Ut plus what? Half AT squared. Half what? AT squared, right? Half AT squared. So for this, since we have to find the highest height, meaning I'm looking for my height, our height, I can either use Y or H, to represent height here. So my height becomes what here? Uy T. Our A, don't forget that here becomes, let me put it, here is our Y, here is what? Our AY, right? AY is minus G, so here will be what? Minus half what? GT squared. Okay, so let's input our values. So our highest height becomes our Uy is 20 times our T is 10. Let's verify. Our T is 2, right? But when it's sub our T to be 2. Okay, awesome. Our T here is 2. Okay. Yes, T is 2. I've seen it. Our T is 2 minus what? Half 10 times 2 what? 2 squared. 10 times 2 squared. So that will give us what here? Our height equals to what? 2 times 20 is 40 minus half times 10 times 4. Okay, so we are going to have here as height equals to 40 minus, okay, 2 here 1, 2 here is what? Is 2. So 10 times 2 is 20. So our height is 20 meter. Our height there is 20 what? Meter. The next question says that we should calculate the time for the ball to return to its original level, meaning find the time of light, the time of light. Don't forget that time of light is 2 times small t. 2 times time to reach the greatest height. And that will give us what? Recall that our small t is already 2 seconds. We have already solved it already. So that means our capital T becomes what? 2 times 2. And that will give us what here? 4 seconds. 4 seconds. The next question says that. How far has it traveled horizontally? How far has it traveled horizontally? How far has it traveled horizontally? Meaning, find your range. The range of this value, our range is equals to what? US times what? Time of light. Abi, this still represent time of light, don't forget. So our range, ROS, then becomes what? US, we are told, is what? 25 times what? Times 4. So 25 times 4, our range is simply 100 what? 100 meter. This is our range. Please, if your line indicates you are your line, this is our range. That is our range. Let's keep on pushing. I hope you are not tired. I hope you are not tired. Alright guys, I think I'm going to stop here, then I'll drop my assignments. I'll drop my assignments for you guys to please make sure you solve the assignments and drop your answer on my WhatsApp page 09063 111 961. This is my WhatsApp number. Make sure you solve the assignments. Make sure you solve the assignment I'm about to draw, all right? The question says that a ball rolls off the edge of a tabletop. A ball rolls off the edge of a tabletop 4.0 meter above the floor and strikes the floor at a point 6.0 meter horizontally from the edge of the table. Find number 1, time of flight. Number 2, the initial velocity. Number 3, how far it has fallen after 0.5 seconds. How far it has fallen after 0.5 seconds. Number 2, assignment. Number 2, assignment. The question says, a level flight bomber flying at 300 meters per second. A level flight. Let me write on the board. And then let me capture some words. A level flight. A level flight bomber flying at 300 meters per second. Flying at 300 meters per second releases a bomb at an elevation of 1.96 kilometers. Question 1 says, how much time is required for the bomb to reach the earth? Number 2, how far did it travel horizontally? Number 3, find its velocity when it strikes the ground. I repeat again, a level flight bomber flying at 300 meters per second releases a bomb at an elevation of 1.96 kilometers. Question A says, how much time is required for the bomb to reach the earth? Question B says, how far did it travel horizontally? Question C or question 3 says, find its velocity when it strikes the ground. When it strikes the ground. Please take note of this question. So I'm going to stop here tonight. Our next class will be tomorrow. Tomorrow by Alright guys, so I don't know, my network was having issue. I didn't know I disconnected already. So I don't know where I stopped. I don't really know where I stopped. So please, this is one of the challenges we always have doing attempt. Hello guys. Trying to find where we stop before this continues. Okay, I think we're going to stop here, right? So guys, we are done for tonight. We are done for tonight. So ensure that you do all the necessary assignment I gave. Please, okay? So please see you guys some other time.